Our discussion about program design is at a Stone Age level. Mainstream program discussion has no idea what a program is, yet will endlessly give people guidelines about how to write one. At the moment, we're in the snake oil era of programming advice. Every single mainstream guideline is wrong. Wrong. Not flawed, not half-truth, wrong. We live in a religious witchcraft era of software, one where idioms, chants, and prayers constitute good advice. Keep functions small. No globals. Don't repeat yourself. Rule of 3, rule of 5, extensibility, maintainability, testability. All garbage. Not it depends, not it's a trade-off. This advice is pure garbage. Why is that? Because the advice is not actionable. What is good code? Code that is clean, code that is easy to read, code that is maintainable. These are tautologies. Nobody can do anything with this. How many small functions does it take to make your code more maintainable? Who knows? So something is deeply, deeply wrong with this advice. We need a new narrative. We need to start at the beginning and derive some guidelines from first principles. So let's start at the fundamentals. What is a program? The internet defines a program as a series of instructions that performs a task. Okay, so how do we write a series of instructions to fulfill a task? Well, first off, I assert that you need to be able to follow the flow of logic of the instructions. If you cannot do that, you cannot make the program do anything deliberate. So let's say that a good program is one where the logic can be followed and it performs the task it is supposed to. This is something we can work with. At the very least, if you take anything away from this video, when assessing the quality of code, use this metric. Does the program perform the task it is supposed to, and can I follow the logic of the program? Okay, but how do I write a series of instructions that we can follow? In a program, there is a flow of execution. We can think of this as a graph that is being traversed. The shape or topology of the graph determines how easy the human mind can follow it. Take this graph. Execution goes one way flow, easy, no forks. Unfortunately, most real-world logic isn't like this and follows some kind of decision making, so something more realistic would be like this. Seems slightly more cognitively difficult. Why is that? It's because there's more edges, there is more connections and constraints between things. It's harder to follow. How about this? This is worse because now we have directed cycles. In a directed cycle, we can return back to a node we previously visited. Cycles require you to jump back to where you were before. This is cognitively harder since the flow of logic suddenly goes the opposite direction. So what is the best topology of a graph? And thus, what is the best topology for a program? It is one where logic flow goes one way. This is called a DAG, or a directed acyclic graph. The dependency chain of this graph is also a problem. The more levels you traverse, the more you have to remember the previous steps. This is primarily why cycles can be bad. It also means deep graphs are hard to keep in your head. Every time you descend the graph, you have to remember the steps to get there. Shallow graphs are good. Because DAGs are easier to reason about, it is easier to reduce them, i.e. factorize and remove edges while still visiting every node in a graph. So let's clarify what a good flow of logic is. The flow of logic in a program is easier to follow when it is a directed acyclic graph. So for a program to be good, we have to be able to follow the flow of logic. To follow the flow of logic, it's better that it is a directed acyclic graph. A good program is one where the flow of logic is a DAG and it performs the task it was supposed to. This is actionable advice. In the wild, if you come across a program, you have the tools to assess its quality. Look at the program at every level, at the instruction level, at the function level, and at the external dependency level. Does the flow of logic go one way? Are there lots and lots of directed cycles? Is the logic shallow or deep? These are things you can actively change and work on. Notice the way I'm not telling you what code to write. That's because a good program really has nothing to do with the code. Go back to the original definition of a good program. It is one that completes the task at hand and the logic can be followed. I call this safe. A safe program is shallow, The flow of logic should have shallow dependencies. Acyclic directed graphs. Flow of logic should try to be a directed acyclic graph. Factorize. Design logic that can be reduced. And factorize where possible. And E, it's easy. And yes, I'm aware this is a contrived acronym. This is also an opportunity to co-opt the word safe in a programming context, because that is a stupid discussion too. This is linguistic ammunition. If you ever find yourself in a discussion about how code is good or bad, just remember safe. You will write good code when you design safe programs. And if this is obvious, remember, the purpose here is to coin ideas that everyone who has programmed for a long time already knows. So that's the end of my presentation. If you have any comments, don't bother if you haven't written a doubly linked list. Other than that, peace.